Hi, Professor. Welcome to my presentation on sustainable element synthesis. My name is Nunez. This is my presentation. First of all, the chemicals studied in the three articles that I chose for the presentation in research. The first one are metal catalysts used for the synthesis of compounds that can help humanity in future generations for things such as food sources or more practical uses such as car development or non-car transportation that can be more efficient not only in its energy use but in its waste production. The biggest five metal-based catalysts use sodium, potassium, calcium, aluminum, and iron for the catalyst used in the reaction. In the second article, it relates to the first article, but it talks about the waste. It uses zinc oxide and dust particles with the zinc oxide for the decomposition of phenols that were created using the synthesis reactions in the previous articles. This talks about the decomposition of the waste and the methods used not only to reduce the pollution created by the methods in the previous article, but how to deal with waste in general, seeing as our planet has limited space and limited resources, so it would make it easier to recycle. In the third article, it talks about phosphorus and nitrogen creating co-doped porous carbons. This is purely for practical purposes rather than like consumption-based sustainability. This is because the porous carbons are used as the molecular formula of the porous carbons and its structure makes it so that it's a hard material but light. It's hard but light, kind of like I can't think of it right now. It's a porous material, so it makes it breathable. It's hard and can take force, but while being light because of the fact that it's a carbon with a hexagon structure. Its application and some important facts. The application for the synthesis of new compounds using sustainable metals is because it's important because most of our planet is made up of metals. So then if we are able to use the metals and its bonds to create new compounds that can help us survive longer, it will be instrumental in the survival for human beings. This is because our planet has very limited resources and we keep making ourselves dependent on the ones that we have least access to. This is such as oxygen, oxygen and carbon mostly. But if we use more metals in our production for energy, if we use more metals in our energy production and in the sustainability of our species, then it'll make it easier for us to survive for a longer period of time. We as a species are dependent on our environment and we exhaust our resources relatively fast. And we're gonna need to start making our own if we wish to survive. However, sustainable element synthesis is the pathway to this if we're going for the long-term survival of ourselves, not only as a species, but as a society in general, since it can help maintain order too. I find interesting about this topic that it brings a new point of view in our human survival. It doesn't focus on the problems that we're facing right now. In fact, it kind of glances over them, but it rather focuses on a separate path that could be taken in order for long-term survival. This is because it demonstrates how far we've come as a species and our understanding of chemical knowledge and not subatomic particles, but rather the intermolecular bonds between certain species of elements. Given to our understanding for this, we're able to we're able to tell what two things can go together and what we can use to survive as well as what we can't use to survive, such as the test that we're using sulfur instead of oxygen for creating other types of life, or silicon. I think this is pretty interesting because I haven't heard anyone talk about this before. The I think that the use of metals, especially for synthetic reactions, could potentially be one of the most important things. If not, I think it has high potential to provide for us. However, there's a lot of controversy surrounding synthetic compounds and especially the consumables. This is because people don't trust something that's edible that was made in a lab. Like, a lot of people are against it because experiments can have mistakes, and when consuming something, if you're gonna make a mistake, it could be potentially lethal, given the fact that it can not only affect your stomach and the fact that it can't digest it, or since we're dealing with metals here, it could be radioactive, or it could react with the hydrochloric acid in your stomach, and it could potentially cause a reaction that could like tear you apart on the atomic level. So this causes worries in the general public. However, the amount of people that are actually educated enough to have a proper opinion on it are very low, since it's a pretty like underground topic. But I still think it deserves recognition in its controversy. Its relation to my career choice. Me, I want to study biochemical engineering or general biochemistry, and I want to dedicate myself to further research of topics such as this one that can like help society, not only society but potentially the world. If this goes well, like if this is further developed and further researched, it could be like super instrumental to us as a species to survive longer. Like, less resources could be used to like deplete our oxygen, and less resources are going to be used to deplete our carbon, since they're all going to be relying on metal, which is what the planet is most composed of. Then the resources from us, not the resources, pardon, the decomposition reactions from the second article could make the waste that we produce, it could make it usable again. It could take recycling to a whole different level. It could like help the world. So I think it's something really important, and I'm really passionate about it. These are all my sources I used. I made sure to be responsible and have credible sources. Thank you for watching my presentation.